Holland, one of the wealthiest nations in Europe, is a country under threat. Killer floods have already claimed tens of thousands of lives and thousands of square kilometers. But the Dutch are fighting back, building a series of unique and complex megastructures designed to shut out the sea. Together, they are the biggest, most sophisticated flood defences ever built. With the final barrier complete, Holland's delta area is now secured. There's just one last vital gap to close in Holland's sea wall. But in this case, the challenge seems impossible, because here there must be no obstruction whatsoever. The new waterway is the entrance to Rotterdam, the Dutch superport. It serves 350 million Europeans and handles over 100 million tons of cargo a year for America and Asia. The waterway must remain open to shipping. But if a flood roars down this open channel, it will threaten over 1 million lives. And the next deadly storm surge could strike any day now. The solution to this dilemma is the most spectacular megastructure of them all. These extraordinary-looking constructions are Holland's latest megastructure. At nearly 300 meters long and 22 meters high, they're the answer to a problem that seemed to defy solution. Rotterdam is the busiest seaport in the world. But this jewel in Holland's economic crown is also its Achilles heel. To blockade the shipping superhighway with flood defences would be economic suicide. But if a storm surge sweeps up this 360-metre wide channel, it will threaten Holland's industrial heart and place millions of lives at risk. So how, on such an enormous scale, can you stop a storm surge racing in from the North Sea without stopping the ships? Yet again, the Dutch have come up with an extraordinary megastructure that's turned the heads of the engineering world.
So they came up with the idea of some large floating structures that could precisely be floated in place and locked in place on really a moment's notice. So this is an unbelievable accomplishment, and it's really a credit to engineering that something like this could even be done. It was doubtful that it could ever be built. Many people doubted that the Dutch could ever do this.
The concept of creating two giant floating gates is both ingenious and daring. Normally open and out of the way of shipping, if floodwaters threaten, these hollow gates can swing swiftly into position. Because they float, the giant gates are under less stress. Once in place, valves in the lower sections of the gates are opened. They fill with water and sink, closing off the new waterway the moment a storm surge is imminent. But for this megastructure to work, the gates must lower onto a flat surface. Extensive trials are performed in a test tank to determine the best materials for the foundations. The challenge is that as the gates close, the gap shrinks. The water rushes faster, threatening to tear apart the foundations. So the designers decide to build their own customized bed. This is perhaps the most spectacular feat of the entire mammoth project. They dig deeper than a two-story building and then build the floor back up in layers of sand, gravel and rocks until a perfect foundation is in place. The permeable layers allow some water to filter through them, reducing the force of flow under the gates so these foundations don't get washed away. Then, 64 630-ton concrete blocks are fitted together on top of this base to form a solid ledge. When the gates are not in use, this ledge becomes buried in silt. But as the closed gates lower onto the bed, the rushing water that gets squeezed underneath through the closing gap blasts them clean, creating a perfect watertight fit. With the design determined, construction begins on the Mammoth project, with teams working around the clock to complete the crucial defences. The bases for the gate's hinges are critical to the structure. Together, they are capable of handling a force of 70,000 tons, and during the heaviest of storms, they'll need to. The ball joints are cast in one of Europe's largest steel foundries. 10 meters in diameter, not only are these the most exact ever manufactured, they're also the largest. Each one is a structure the size of a house, built with the precision of a watch. They arrive at the barrier by sea and are fitted into their colossal concrete bases. The trusses, made of up to 9 centimetre thick steel tubing, are each assembled section by section on site. It takes 160 hours to weld each joint, with the work done in a controlled environment inside protective tents to avoid any contamination of the welds. The whole arm will only be as strong as its weakest weld. When finished, each gate is almost as long as the Eiffel Tower. These 300-metre-long arms are the final part of the most complex sea protection system ever built. The linchpin of the whole project is the computer-controlled decision support system, codenamed BOS, BOSS. Only this computer can decide if the gates are to close. It receives constantly updated weather and wave height information from ships at sea, remote buoys and weather stations. The decision to close the gates relies solely on the computer predictions. People can't decide when or if to close the gates. The decision is too important to risk any human error. They must wait on a computerized hair trigger. In 2002, the gates get their biggest test yet. (27th of October 2002), and the water level predictions aren't looking good. A prolonged period of rain has filled the rivers to bursting. At the same time, an area of low pressure is moving down the North Sea. BOSS, the automated barrier closing system, is predicting a sea height 3 meters, almost 10 feet, in excess of the maximum safety level. It's red alert time. BOSS automatically triggers the barrier closing sequence. At T-4 hours, a warning goes out to all shipping. At this time, the dry docks where the gates normally rest begin flooding, ready to float them out into position. T-2 hours, all shipping is halted. If you're a vessel in port, you stay put. If you're out at sea, good luck. At T0, the gates should begin to close, but this time, they don't. Boss has been crunching the numbers, and the new storm surge is now 2.99 meters. That's still a wall of water way over the heads of most people, but it's not enough to trigger closure.
We did all the preparations, but we didn't close the barrier because there was 1 centimeter shortage of water.
The computer has held its nerve, trusting the forecasting data and aborting the closure sequence. The reason it's left entirely to a computer is that a human being, particularly one with a family or home the other side of the barrier, might act differently.
If you think the water is that high that your house is going to flood, you close the barrier. The computer don't.
The shipping companies, the lifeblood of Rotterdam, are happy that an unemotional machine decides whether or not to shut down their main waterway. The barrier management put their trust in Bos. If the worst should happen, a storm surge will be halted and the people and businesses behind them protected. So with the last opening in Holland's North Sea wall now closed, surely it must be time to relax. Finally, are the Dutch safe? The answer, yet again, is no. In the latest cruel twist, climate change and sea level rise are now threatening everything the Dutch have done so far.